Permutation. How do we use it? What is it? Permutation determines the number of possible arrangements where order matters. Why? Helps to describe RNA sequences. Interesting fact, the white rhino can weigh over 3,500 kilograms or 7,700 pounds. Now, let's take a look at the definition of permutation. Let S be a set of n elements, and let 1 less than or equal to r less than or equal to n. A permutation of r elements of S is an arrangement without repetition of r elements. What does that even mean? Well, we will put that into action so we can find out. Now, let's talk about the theorem on the number of different permutations. Let S be a set of n elements, and let 1 less than or equal to r less than or equal to n. The number of different permutations of r elements of S is n permutations of r is equal to n times the quantity of n minus 1 times the quantity of n minus 2 times times the quantity of n minus r plus 1. This will help us find the number of different positions. Now, let's talk about the formula. If n is a positive integer, and let 1 less than or equal to r less than or equal to n, then n permutations of r is equal to n factorial all over the quantity of n minus r factorial. Now, let's put all this into action by taking a look at an example. Let's say we have a 4-digit code for either an ATM card or phone. The first pin will have 0 restrictions, while the second one will have some restrictions. Let's start with the first one. So the first number could be any of the numbers from 0 to 9, so 10 options. Once again, this pin doesn't have any restrictions, so the password could be any number. So we could use the same number for each of the other 3 slots. So how many outcomes do we think we have with this scenario? Well, since the numbers are happening simultaneously, we multiply them. So we have 10 to the 4 or 10,000 outcomes with replacement. Now, let's say the password has rules, and we cannot use the same number again. The first number still has 10 options, the next one 9, then 8, then 7. Once again, they happen simultaneously, so we multiply the numbers together. So how many outcomes do we think we have with this scenario? That is correct, 10 times 9 times 8 times 7, which is 5,040, without replacement. Now, we can write this outcome using factorials. Do we know how we can do that? That is correct, 10 factorial over 6 factorial. And we can rewrite that as 10 factorial over the quantity of 10 minus 4 factorial, which is the permutation formula n factorial over the quantity of n minus r factorial. Using the numbers, we can write that as 10 permutations of 4. Now, let's take a look at the examples we're going to discuss in today's video. Let's take a closer look at example 1. Now, let's read the steps. Step 1. What is n? The object. Step 2. What is r? The position. Step 3. Use the formula. Step 4. Follow order of operations. Now, let's read the question. Evaluate, where we have 6 permutations of 3. Now, let's write down the first formula so we can figure out how many positions there will be in 6 permutations of 3. Remember, n is the number of objects, and r is the number of positions. In the formula, we only need the quantity of n minus r plus 1, or the last term, to figure that out. Now we need n and r. And n is 6, and r is 3 in this case. So let's substitute 6 for each n, and 3 for each r. So now we have 6 minus 3 plus 1, and the result of that is 4. So now we know the last number in the last position, which is 4. Now, let's write down what 6 permutations of 3 is equal to. So, 6 times 5 times 4. We use 6 because of the number on the left and 6 permutations of 3. And we have 3 slots because of the number on the right and 6 permutations of 3. And 6 times 5 times 4 is 120. So we have 120 outcomes. Now, let's use the formula. n permutations of r is equal to n factorial over the quantity of n minus r factorial. So let's substitute 6 for each n and 3 for each r. So now we have 6 factorial over the quantity of 6 minus 3 factorial, and 6 minus 3 is 3. So now we have 6 factorial over 3 factorial. Let's get rid of those factorials. So we have 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. Let's simplify. All the 3's, 2's, and 1's cancel. So we are left with 6 times 5 times 4, just like with the first way. And 6 times 5 times 4 is 120. And if we use the pen to solve it, the first number has 6 options, the second number has 5 options, and the third number has 4 options, since permutations is without replacement. That is example 1. Let's move on to example 2. Now, let's read the question. Evaluate where we have 2 permutations of 2. Now, let's write down the formula so we can figure out how many positions there will be in 2 permutations of 2. Remember, n is the number of objects, and r is the number of positions. In the formula, we only need the quantity of n minus r plus 1, or the last term to figure that out. Now we need n and r. n is 2, and r is 2 in this case. So let's substitute 2 for each n, and 2 for each r. So now we have 2 minus 2 plus 1, and the result of that is 1. So now we know the last number in the last position, which is 1. Now, let's write down what 2 permutations of 2 is equal to. So, 2 times 1. We use 2 because of the number on the left and 2 permutations of 2. And we have 2 slots because of the number on the right and 2 permutations of 2. And 2 times 1 is 1. So we have 2 outcomes. Now, let's use the formula, which is n permutations of r is equal to n factorial all over the quantity of n minus r factorial. So let's substitute 2 for each n and 2 for each r. So now we have 2 factorial all over the quantity of 2 minus 2 factorial, and 2 minus 2 is 0. So now we have 2 factorial all over 0 factorial. Let's get rid of those factorials. So we have 2 times 1 over 1. Remember, 0 factorial is 1. Let's simplify. All the 1's cancel, but that is not really necessary, but we can do it. Why not? So we are left with 2, just like with the first way. So our answer is 2. And if we use the pen to solve it, the first number has 2 options, and the second number has 1 option, since permutation is without replacement. That is example 2. Now, it is your turn, so go ahead and pause the video here so you can take your time to answer this question, and I will show you the result in 3, 2, and 1. Did you get it correct? Fantastic. If not, there's always tomorrow.